Hello folks, my name is Ed Overstreet and I have a YouTube channel called the Night Sky Imager, and tonight I am going to be doing some deep space imaging. While I'm waiting for my target to transit, which is about 30 minutes from now, I'll double check that, but I've been playing around with taking some images of the moon, and I was going to share my screen with you and show you what's up there tonight. One second while I go find it. Wrong, that's the other telescope. That says the right telescope. Let me hang on just one second. And I'm closing some boxes that you can't see and some you can. We are currently taking shots of the moon. I am hang on, I'll show you what I'm doing. I'm taking 3,000 second shots at f7, and again it's a high gain of, it's kind of like a high ISO, but it's a high gain camera. Or I've got the gain set to 200, which is pretty high for the ASI 1600, although I image at that all the time at that gain. Don't know why my moon is moving out of the frame, so I'm going to kind of reposition it. And there we go. But we're in a waxing gibbous. We're at the first quarter. Actually, we're one day past the first quarter moon. And in about 8 or 9 days, well, less than that, there'll be a full moon. And then we'll go into a waning phase, third quarter, and then a new moon. And then it repeats itself. But I mentioned to you that I'm waiting to start imaging. I want to bring up my target for tonight. I'll be imaging M104, which is the Sombrero Galaxy. I started imaging this a couple of nights ago, and clouds stopped me dead in my tracks, but I did get 10 images, taking 240-second exposures. Those are 4-minute exposures. And I have what's called an IR UV cut filter, and that's to kind of mitigate the moon light pollution. This camera is the ASI 183 MC Pro. It is a color camera, so I'm not using a filter wheel, and I'm not using luminance and red, green, and blue filters to record a color image. Instead, I am using a one-shot color camera, as we call them, but it is an astro camera. Let's go outside here real quick, and I'll show you the telescope that's right now zeroed in on the moon. It's this one right here. I hope my cursor is active on your screen. It's active on mine. This is the Vixen 625 ED81S. It's 81 millimeter, 625 focal length, and I don't have a reducer on it. This has a very flat field from corner to corner. It's probably my favorite refractor, kind of an intermediate focal length for me. And also waiting to start imaging is the Stellar View 70T, and that's let's go over and look at that setup. Let's bring up, we're going to be doing the 106 Sombrero Galaxy, and this does have a filter wheel. It is a mono camera. It's a 1600 ASI 1600 mono. So I'll be taking 30-second exposures in luminance, 90-second exposures in the red channel, the same for the green channel, the same for the blue channel, and I'm going to be taking some hydrogen alpha. And this is a very narrow band pass, so I have to increase the exposure time. I don't need as many, but this is a spiral galaxy that has a lot of star-forming regions, and those can be best identified by their emission of hydrogen alpha. So we're going to take some hydrogen alpha, and we'll be able to pinpoint those star-forming regions in this galaxy. I'm going to go ahead and get things started. I'm going to activate my power control. I'm going to turn on the power, and I'm going to turn on the power to the mount, to the focuser, and to the camera. I already have now the dew filters working, so we're obviously going to have some dew issues tonight. I'm going to bring up my driver for EQ ASCOM, and I'm going to connect my telescope's hand controller, and there we have it. And now I'm going to connect my camera. I'm going to go ahead and turn it on, and I'm going to start cooling. I'm going to cool to minus 20 degrees centigrade. Connect the filter wheel, connect my focuser, connect my mount, connect my weather station that controls the dew field and humidity and temperature information. It puts that data in each picture file. It's written into its code, so I can, if I need to see that information, it's helpful when you need it. I'm not sure what time I'm going to start imaging this, so let's go to planning tools. Okie dokie, I can see what I'm doing. I'm just waiting until it transits. It's about 10 minutes away from transiting, which means that here's the target, and it's going to pass the transit point and then start going, it looks like downhill, but it's going to be moving, crossing the southern meridian, and it's going to be moving towards the horizon along the celestial plane. So I'm just going to wait so that I don't have to flip the mount until it's time to start imaging then. But I want to go ahead and cool the camera down, and it'll be ready to rock and roll. It's at 14 and getting cooler. I'm going to keep my outside, I'm going to keep the outside camera active. We're at 13, and it's going to take a while to cool down. We're at 12.5 centigrade, and it's doing its thing. Okay, let's go back to our other. Get rid of. Let me make sure. What time did I say we're going to start This is, oh, it's already transited. It's at 10:13. So, no, it transits at 10:13. It hasn't quite done that yet. We're awful close, though. So, within the next 30 minutes, I will be imaging something other than the moon. So let's close that. I'm going to wait and start both targets about 10:15 tonight and let them run most of the night. Don't think I've yeah, I did activate the weather. Okay, let's close this out and look at the moon again. And you can see how my the moon has drifted off to the left. So let's bring it up. See if we can't get it centered again. And then let's bring it down. Wrong way. Let's go. It's fighting it. Yep, I am pushing it the wrong way. That's why. I'm dyslexic. Here we go. Here we go. Now let's go up and to the right, which is west. All right, we're getting close to being centered. Okay, let's click on the moon rate. So we're now in, we're not tracking at sidereal, we're tracking at the lunar rate. The stars track at sidereal, deep space, galaxy, stars. They have their own clock, if you will, and the rate at which you track them is called sidereal. The sun you're going to track at lunar, and I mean it's solar, a solar rate, and it's slightly different than lunar. But here is the sidereal rate. So right now, as you can see, we are taking one image right after the other and downloading them, and this is what you're seeing. It's taking an image, it's downloading it, you're seeing it. So I've acquired a bunch of images since I have been, since I booted up and started this. But it's a pretty special part of the sky, and I don't often look at the moon. On a night like tonight, when I'm kind of waiting around for my targets to get in a good strategic place for me to start imaging, is when I tear off and see what's going on. Let's zoom in a little bit and kind of see what's going on with Mother Moon. Bring up our hand controller and we'll kind of we'll head up. Y'all can be looking for the flag. I don't know if you can see this out there in internet world land, but this is an image that has a Bayer matrix to separate the red, blue, and green channels, and it's like a checkerboard. I'll see if I zoom up just a little more. Let's zoom up to, hang on a minute, say 200%. Is it going to do it? I don't think it's going to do it. There you go. Now that I've zoomed up this close, you can see the checkerboard. And this is indicative of having a one-shot color camera, as each one of those little squares has 4 photo cells. One green, two green, one blue, and one red. And when you remove the barometrics, this will turn out to be a color image, and that's called debayering. So part of the processing of these images is to debayer them, which is to convert this black and white into a color image. So let's go back to not quite that rich of a zoom, and let's bring up our hand controller, and let's start moving around and see if we can see one of these days we're going to watch an asteroid strike the moon, and we'll have a picture of it. That's what we're going to do. Isn't it amazing stuff? Each one of those craters are a result of being bombarded by meteors, asteroids. Rocks and ice flying through the sky, getting caught up in the moon's gravity and pouncing on it. Looks like it's got a skin disease. Fascinating. If you're just joining me, we're real-time imaging the moon, and I'm moving the telescope around the moon's surface, the lit part, obviously. The moon is past the first quarter by 1 day, maybe 2 days. I was thinking the first quarter was yesterday. It's close enough. About 60, I think 66% of it is illuminated right now. Another 7 or 8 days, the whole thing will be full. It's kind of magic. Again, I'm imaging the moon. I'll cancel that. This is a telescope that right now is imaging the moon. Hopefully, y'all have been seeing the moon. I didn't have that whole telescope thing on Facebook this entire time. I've been looking at the moon. You may have been looking at the telescopes. At any rate, we're on the surface of the moon, I don't know the moon well enough to name the mountain ranges and but every one of every one of these craters has a name. Nor do I really want to know the moon that well. I'm just like you and like others, kind of fascinated that it's so pitted with craters from asteroids, meteors, crazy things flying through the night sky, striking it. This is a mountain range going here and there. Okay, let's go back to bring our hand controller back up, and let's start moving up. A lot of people feel like the full moon is the best time to image the moon, and that's really not the case. When the moon is full, the sun is striking it directly, and you really can't see these craters. There's no depth. But when the moon is being lit at an angle by the sun, you see the sun is cascading over these craters or over the surface, and we're getting to see the shadows from this mountain range. And of course you can see the definition much better of these craters. They almost look like bumps, but they are not. They're not sticking up, they're going down. It's kind of an illusion. Alright, let's continue to go up the dark side. You think we'll ever see a McDonald's on the moon? Why not? If we do, I'll promise you there'll be a line of lunar mobiles waiting to get their McRib. What a sandwich. Oop, wrong way. Boy, when you go to the dark part of the moon, there is no way of pulling out anything. Okay. We've gone from one side to the other. Wow. And let's go back and make it smaller. There she blows. Bring up my hand controller, and let's change the speed to 2 times sidereal, and it'll move a little faster. And we want to go, I need the telescopes because I'm going to be slewing to different targets in a few minutes. Oh, wrong way. There it comes back. And another hit. That'll almost center it. There we go. Let's activate lunar tracking. And there's our nightlight. Let me see, it is 10 o'clock. And I think I do believe we have passed transit on, yeah, this was 9:55. So I'm going to go ahead and slew to my target, and we are now headed there. I'm going to bring up the telescope, and this is the telescope that's now going towards M106. M106 is a spiral galaxy that I'm going to image with a very wide field setup. So it's going to be kind of small. I need a longer focal length, but I wasn't in the mood to put on the bigger scopes. And I sometimes like to see the wide field view. We can get rid of that. Now we're going to center our target. It's got in the general vicinity of M106, and this is called plate solving. I'm activating a software algorithm that does nothing more really than take a picture of the sky. There's M106, by the way, and it takes a picture of the sky, and then it compares it with a catalog of the night sky, a planetarium software, and then it will solve and nudge the telescope. Just now it nudged it to the center. So my galaxy is within 13 pixels in right ascension and is within 9 pixels of declination of being dead center. So that's close enough. And I'm going to continue imaging this in the luminance channel first. I want to make sure that I am at minus 20 degrees, and I need to run the focusing algorithm, but let's go ahead and start this. And it should automatically start focusing. Oop, I haven't started my guider. We're going to have to do that. Alright, let's find the guide star, and let's start guiding. So we are now guiding. Guiding is a process by which, incidentally, before I go to guiding, this is the focus system. Automatically, it's taking different images and moving the telescope's focuser out of focus and then back in focus, and it will determine the best focus by creating a kind of a cross here, and at that cross center is the best focus. It's difficult to focus on stars and know for sure that you've got a sharp focus. I don't care how good your eyes are. So I trust these focusing software programs to do that for me. But let me go outside and bring up the outside camera. This is the main imaging telescope. I'm looking at the very first telescope on the pier, the one closest to us. And the telescope on top is a guiding telescope. And attached is a camera. And the camera is connected to the computer. And it's taking pictures of the same part of the sky that the main telescope is. But it's only taking pictures and focusing on one star. So when I bring up the guiding software program, which is called PhD2. This is the star where these crosshairs are. And here's another way of seeing that star zoomed in. And it's going to watch that star and send corrections to the mount when needed to keep the mount pixel on pixel, so that when you're imaging, if you have any tracking errors at all, then it helps to correct for those errors and keep your target dead center and pixel on pixel. Okay, we had a successful focus. It was set to 10,000 steps, 10,854. We've taken a 30-second exposure, and this is what it looks like. So our first exposure at 30 seconds shows us really very little because it's so far away, and I got such a wide field. But we'll zoom up a little bit, and you can kind of see the outline. We're collecting a few photons at a time, and we're going to take so many images. As a matter of fact, we're going to, when it's all said and done, we're going to have 50 luminance pictures, 40 red channel pictures, 40 green channel pictures, 40 blue, and 20 in the hydrogen alpha narrowband images. There will be 4 hours, a total of right at 4 hours of total imaging. And when I start combining all of those pixels together, and it will take at least tonight, I may have to do this another night and get 8 hours. My average picture is a little over 8 hours of imaging time. My average deep space picture is over 8 hours of imaging time. So some targets like Andromeda or the Orion Nebula, they are so bright that you can get by with less time. But let's say M106. Let's go find out where M106 is. And let's get some information on it. I'm going to bring up, hang on a minute, you'll see the screen. You got to see me first. I'm bringing up a planetarium program that you can't see bouncing around down here. It may be messed up. Okay, here we go. Let's type in M106. And all right, here it is. Actually, it hasn't transited yet. It's about to, well, are we? Yeah, we're on current time. It transits at 9:52, so it's already transited. I'm not sure why. Oh, we're going from, we're in the north part of the sky. I didn't realize that. I thought it was in the southern meridian. This is what it's going to look like, prayerfully, when it's all said and done. Let's find out how far away this thing is. It's 25 million light years. It's between 22 and 25 million light years away. And it's receding at 537. It's moving, it's expanding, and it's moving away from us at 537 kilometers per second. I mean, it's boogieing away. But it's between 22 and 25 million light years away. Think about that. Light travels at 186,000 miles per second. And put it in perspective, if you were at the equator of the Earth, and you shined your brightest light, it could go around the Earth 7.5 times in 1 second. That's how far light travels in 1 second. So imagine how far light travels in a year. And then 25 million of those years, that light has been moving towards my camera, and now I am capturing it. So we have already started imaging this little booger, and that light that you're seeing, not from the stars, they're at various points in deep space. Some are even further than 25 million years. Here's a galaxy up here, much smaller. Here's a galaxy over here that's much smaller. Here's one here. Here's one here. It doesn't necessarily mean they're closer or further away, but chances are they are further away. And but this is 25 million light years away. So this light has been moving towards Spartanburg, South Carolina at 330 Millhaven Drive in my backyard at that telescope for 25 million years. It's kind of a mind-blowing. It's mind-blowing for me. And I do this quite often, and I still get my mind blown. All right, let's check out our guiding before we go start the other one. These spikes are normal because I'm doing what's called dithering. And when you dither, you deliberately move your telescope between imaging. And this is a procedure that you'll use to help to mitigate the noise that accumulates when you're taking long exposures. I won't spend any more time on that, but it is a deliberate decision on my part to dither at the end of each frame. Some people will dither every 2 or every 3 frames. Some won't dither at all, but it does definitely improve your imaging overall. It's not a real great night so far. RMS is at 117, and I'm going to probably, when I go offline, stop the streaming, run outside and make sure my cables aren't hanging on something. And that's probably what's going on. I can improve that. It's not a big... That's acceptable at this focal length because I'm at 338 millimeters focal length. That isn't going to create any oblong stars. But when you're at focal lengths of 625 or 1,000 or 3,000, this is unacceptable, and you would just have streaks and stars that are oblong, and because your scope's moving, and that's being recorded, and it can't hardly be dealt with until you improve your guiding. Let's see. Let's bring back. We are now at 43 pictures, and let's go on over to the other telescope. It's ready to stop imaging the moon. And let's bring up the Sombrero Galaxy. And we're going to, let's stop, I got to stop this. Let me cancel this. Let me stop this here. Come on, stop. All right. Now we're going to head over to the Sombrero Galaxy. Let's go find our... Okay, it just made a decision to move in the sky to another position. We're now going to center. We're in the general area, But we're going to now center our target. Hopefully we won't have any issues. That background noise that you're hearing, it's the outside camera. It has sound. Okay, let's see how far off we are in our first picture. Ooh, we're way off. We're 2,231 pixels off. And but it'll find it, and it'll figure it out. We ought to be getting closer. These one-shot color cameras make the auto stretch. We're now at 68 pixels and 18 pixels, so we're much closer. The Sombrero Galaxy really does kind of look like a sombrero. It's kind of funny. Some of the names that astronomers have given to deep space, we're off quite a bit. We're off 30 pixels in RA, 0 pixels in DEC, but that's fine. I want to do an auto stretch from now on, and we'll have something to see. But let's go ahead and let's make sure we get a good guide star. And we want to go to we're going to go to about 3 seconds and guide at 3 seconds. And let's click a guide star. And let's start guiding. I can tell I'm now guiding. I can see at the bottom left here, it says guiding. So we know we are, and we're already seeing some corrections. Normally I like to let this guiding start and run for a while, maybe 5 minutes, so it can settle down. And I will look and see how my guiding is going, and if it's acceptable, start imaging. If it's not, I go out and first make sure that my cables are in a position, in a good position, and not snagging on anything or dangling. Also, I'll take another kind of a wind check and see what kind of wind or breeze might be blowing outside, and that can mess up your imaging, particularly when you have high focal lengths. But this is really not good, and but because I'm doing this live, I'm going to go ahead and just let it rip. I'll play around with it later, but let's go ahead and let's take an image, and then I'm going to sign off. And let's see what we're going to have to first probably do an autofocus. And it's going to recenter the target. And the reason why I know is it says it's slowing to target. Okay. It had to... this software is just brilliant, but if it had any drift, then it was corrected then when it recentered the target. But it shouldn't have had too much, because I was able to there's my Galaxy right there, and it's going through the focus routine right now. I can go ahead and get rid of the cameras outside for the time being. Now, this is crazy. We're getting some crazy readings here. This typically is just a V, and I'm going to cancel this and start it again. Just cancel. And this should move me back to where I was. It's going to recenter. Target. Okay. You can see the checkerboard much better on this longer exposure. We're 56 errors off in RA and 2 off in deck, so it's going to get us a little closer. I like to get inside a combined 50 pixels, and it's at 56. And by doing that, then tomorrow night, when the games are over at Dorman, I'll be coming back here and imaging the rest of the night, because it's going to be a nice skies. And you can see it moved it. It moved it while I was actually taking a picture, so we see these streaks. It moved it too far. We're 2 pixels off in deck, and we're 116 pixels off in RA. Okay, I think we're back, about fixed it. Now we're back to instead of 56 pixels, we're at 55, so we improved 1 pixel in this whole mess. It was 56 off, now 116, now 55. I'll let it run one more time, but it's close enough. I'll just abort and start imaging. Okay, it found it. So it's resuming the auto guider down here in the bottom left. It's starting the guider for me. That's what this software does. It talks to the guide software, and we'll bring it up to make sure that. Let's clear this and start from scratch. And we started guiding again. And so let's go back to our acquisition software, and I want to Okay. I'm going to move this over slightly. But what you're able now to see is the galaxy kind of taking shape. We're taking 240-second images, 240-second long images. Down here on this first image, we're at 166 seconds. We are out of focus, though, I can tell from my stars. So I'm going to go ahead and make sure we run the focus routine again. And I'm going to click on it. And so as soon as this has taken its first image, I'm going to delete that image. I'll delete this one too. And we'll refocus. I'm going to wait till this comes in so that you can see what it looks like. This image is a result of the plate solving, which were just 10-second images. This will be this will show a little more information. I have a feeling though the guiding's going crazy. Yeah, it's not good at all. I'm going to go up to 4 seconds. Clear out. And I don't, probably chasing some terrible scene. We're at now 87 seconds left in this first image. I was able to take 10 of these images a couple of nights ago. Clouds came and ended the night early, and I'm just picking up where I left off. So we have 1 minute left, and as soon as we see this one image, I'm going to stop streaming and end up going outside and see if I can figure out if there are any external reasons why I'm getting these guiding, why this guiding is so far off, because it's unacceptable. I couldn't image all night at that guiding rate. I may have to recalibrate this mount, which just takes an extra 20 minutes or so to recalibrate and then run the guiding assistant. But it's pointless to try to image and get good sharp stars and a good defined galaxy if your guiding's off. So you got to fix it. It may just mean I need three nights. Okay. Oh, bully. I forgot I started the autofocus, but while it's autofocus, oh, it won't let me. Autofocus is going to run its routine. So it defocuses, and then takes another picture, and it moves the focuser, and you get a little sharper focus, and then it takes another picture, it focuses it again, and we're getting the same mess. But at any rate, I think I know why. I do know why. And it isn't going to get any better until I start out with a sharper focus. So what I'm going to do is go ahead and cancel this, and yes, I want to cancel. All right. I want to go back to the image I took, and I want to stretch that correctly. Okay. All right. This will kind of give you a little bit of a view of the galaxy, but you can see that my stars are kind of oblong and not sharp, and this really shows you on the shape of the stars, and that's just a result of poor guiding. And once I get the guiding fixed, then those will be they should be like pinpoints of light. But this indicates that there's a problem, and it's going to be reflected in this galaxy, although it's not nearly as noticeable. But the data just doesn't line up as sharply when you're not in focus anywhere in your image. So, with that being said, what I'm going to do is say goodnight to you, but I'm just getting started. And have a great weekend. I will say this. If you are a Dorman Cavalier sports fan, tomorrow night, starting at 4 o'clock, Dorman will be having an inter-squad spring game scrimmage, football. And then at 5:30, the girls softball team will be playing for a district championship. They'll be playing Fort Mill. And then the Dorman baseball team will be also playing at 5:30 for a state championship. A district championship, and they will be playing J.L. Mann. And it ought to be a good night of sports, and that's where I will be. And once that's over with, I'll be back here, booting up and picking up where I left off tonight. So you guys have a great weekend, and see me back online. This also will be uploaded to my YouTube channel, Night Sky Imager.